Welcome to the MSJC Internet Authoring Videocast.
Welcome to Lecture 6. In this lecture, we'll be covering random numbers, while loops, and jumps. So we start with random numbers. We can use the random class to generate random numbers. To do that, then we must import the Java util package, which contains the random class. So once we have imported the random class, we'll need to create an instance then of the random class, just like we did with the scanner class. So the example you can see here is we're creating a variable of type random, calling it RND, and just assigning it to using the new operator with the random class. So the random class has several methods: nextInt, where we incorporate a scaling factor, and we'll look at that a little bit later on. NextFloat for float types, and nextDouble for doubles. Now, I want to make you aware of the fact that we'll be using the random class in our examples, but there is a newer class. It's called secure random. The problem with the random class that we'll be using is it does not produce non-deterministic random numbers. In other words, hackers could actually hack a program that uses the random class and be able to actually predict the numbers that would be quote-unquote randomly generated. So the package that you find the secure random class in is java.security. But like I say, in this class, we'll be using, all of our examples will be using the random class. So to create random numbers, we will use one of the methods on the instance that we create of our random class. So we use nextInt. We're going to generate a whole number between negative 2,147,483,648 and then the positive side of that. It's a 32-bit, right? Integer's 32-bit, so that's the range of 32-bit integer. Using double, which is going to give us the ability to have decimal places, the number that's derived is actually between 0, which is inclusive, meaning that 0 is one of the numbers that we could arrive at, and 1, which is exclusive, and you would have to actually use scaling to get the value of 1 if you wanted to. But realizing that would just give you basically 0 or decimal values. So as I said, we can scale the number, because obviously you wouldn't want a random number that's always between negative 2 billion and positive 2 billion. And think of a dice game where you only have 6 sides, or a coin where you only have 2 sides. So we use this concept called scaling, and the idea is that when we generate the value that is going to be the random number that we assign to a variable, so if you look under the heading there, can scale using, you'll see here we're giving you an example of a int variable that we're naming num, and it's going to be assigned the result then of our random variable. So that's the one that's the instance, right? That's the object that we created after we created the instance of the random class. So RND, which is our object, and then using its nextInt method with a value of 101 inside of it. So that 101 in the parentheses, that's we're passing a parameter, actually technically an argument, into that method, and that would be called a scaling factor. So in this case, we would be scaling down the random number generator so that it would only generate a number between 0 and 100. Now we can modify that even further. So you might think, well, why we use 101 there? Well, you have to remember that you're starting with 0. So if you would actually count from 0 to 100, you would get 101 values, right? So if we wanted to start at 1 and come up with a number between 1 and 100, then what we would do is we would add a shifting value. So in the last example, you can see there when we create the int num, we start out with the number 1 being added to the results of our random number, and notice the scaling value, the scaling factor there is 100. So technically now we're only going to get the values from 1 to 100. Now, if we want to have a specific range identified, like we gave you in the last example of the last slide, from 1 to 100, this is just another example of that. Just say we want to generate some random characters between the letters A and Z, capital A and capital Z. So if you think back, You might recall that the capital A is the value of 65, capital Z, value of 90. And so the way that we could set it up so that the random number generator would only give us characters within that range, we can set up a statement here where we have an integer named num and then assigning to it our random object, next int. Now we've got a little bit more complex scaling and shifting going on here. So what we're starting out is we're taking the maximum value and subtracting the minimum value. So that's going to give us then the number of characters that we want to have within the range, and then we want to add 1 to that, and that will give us our scaling value. And then we're adding to that the shift value, which is the min, so that's the starting point. In the previous example, we had the number 1 plus, and then the actual random number. Here we're adding it after the fact. It doesn't matter either way. I mean, you could rewrite this statement here where the min value is on the right side of the assignment operator, but before the rnd dot next int. So you could have min plus and then the random number that we're generating. So remember that inside of the parentheses, that's the scaling value. That's how we're generating what the number of characters should be, right? So the maximum minus the minimum plus 1, and then shifting it to the value of min, which is 65. So we've got the number of characters within the parentheses. The starting or the lowest value that we'll want it to ever generate is the plus min on the end. And then you can see that implemented in the code there below. Now we get to the while loop. So the while loop uses a Boolean test condition, just like the if statement. The way that a while loop works, in fact, when you look at the graphic that we have on the screen there, you'll see that you have the keyword while, and then in parentheses is the Boolean test expression. So again, very much like an if, the difference is we're not testing to branch to a particular direction. We're testing how long the loop should continue in this particular case. So after we have the while and the Boolean test expression, then we have the open and closing curly braces. And inside of the curly braces is the loop body. That's where we're going to put all the statements that we want to have executed each time through the loop. Loops are interchangeable. We can use a for loop in place of a while loop and vice versa. You can create a counted loop with while. You simply need to create all of the components that you would expect to find in a for loop. So you can see there on the right, we give an example of that. Outside of the while, we initialize our counter variable I, assign it the value of 0. And then we generate the keyword while, and in parentheses the Boolean test. So we're going to loop this as long as I is less than 10. Then we have several statements within the body, and notice within the body then itself, we also have the update, the incrementing of our counter variable I there. So that moves us towards our bounds. Now this is susceptible to errors from a programmer standpoint because each section is not all together like it is in a for loop, and many times it's easy to forget the update expression. So here's an example of a counted while loop. Here we're going to take input from the user, which is going to be assigned to string s, and then we've created two variables. Sum is where we are going to track the values of all the characters in the text that the user types in, and then our counter variable is going to be integer I there, which again we initialize a value of 0. So we're going to run this while loop as long as I is less than the number of characters in the text that the user has typed in. So we're using the S variable, which if you look up above on line 7, it's of string type, and it has a length method. So that tells us how many characters are in the text that the user typed in because we assigned that value to the S variable. So s.length will tell us how many characters are in there. So we just run this while loop, going through one at a time, looking character by character, analyzing what each character's value is. So inside the body there, you can see that we're using the char at method of the string object. So s.char at, and then I starts at 0. So that's going to be the first character in the string, and then loops back through. It increments by 1 each time through. We update the counter there at the bottom of the body, I++. So each time through, we're incrementing I by 1. So we look at the first character, we get its value, and we're actually converting it to an int here because it's a char that we're getting, right? So the char, remember, is only going to be 16 bits, and we want to convert it to 32 bits, an integer type. So what we're doing is, in parentheses, we have the word int there. That's called casting. And what that's doing is that's telling the JVM to convert the value to the right of it, so the s.char at I, that's whatever the character is that we're looking at. So whatever that numeric value is, convert it to an integer value, and then assign it to the sum variable. And notice we're using the plus equals operator there. So that way sum just keeps accumulating the values of all the characters as we go through the string. And then, as I said, we're updating the last line in the body there is we're updating our counter each time that we go through. So then once we reach the length of the string, we'll exit out of the while loop, and then the statement that is on the outside of the while loop then is just simply stating how many, or what the sum is of all the characters that were contained within the string that the user typed in from the keyboard. Some of the common source of errors that you'll encounter: it is easy to introduce logic errors so that you can write for loops correctly the first time, mainly making sure that you have the appropriate counter variable, that you're updating it to move to your bounds, and that you have a proper Boolean expression so that it will exit from the loop. So some of the problems you run into would be using an expired counter. So you want to make sure the counter is created and initialized properly. Make sure it's a precondition of the while loop, meaning we'll assign that value before we go into the loop. And then endless loops can be a problem too, that occurs when we're not moving to the bounds, towards the bounds, meaning we're not updating the counter variable properly, or we don't have the correct Boolean expression to escape from the loop. Now here's an interesting example called the Phantom Semicolon. So in a while loop, there shouldn't be, it's not a statement. It's really like an if. You've got a header with a block of statements that follow. So you don't want to have a semicolon after the Boolean test expression. So in this case here, what we're attempting to do is count down till 0 and then run this function called liftoff. But because you have the semicolon there, you're going to have an endless loop. And then if you happen to prime countdown prior to the loop and you assign it a value of 0, then the body would only be executed one time. Indefinite loops, or indeterminate loops, might be a better way to say that. That's the example that we're looking at here. The bounds in this particular case is we're waiting for the number 50 to be generated. So if you look down into the body of the program that we have, the example there, you can see that the Boolean expression for the while loop is going to run while the number is not equal to 50. So the whole idea here is what we're doing is we're running a random number generator, and every time that a number is generated, we want to check to see if it's 50 or not. The main thing is here to understand that this is indeterminate because we have no idea how many times that this loop is going to execute. It's unknown. So, it could run 10 times before 50 pops up. It could run 100 times before 50 pops up. We don't have any idea of precisely when that's going to occur. Now we'll get into Sentinel loops. So we looked at counted loops. Now we're looking at and then indeterminate loops, and now Sentinel loops. So Sentinel loops are a loop that looks for a particular value, like we saw in the previous example there. Typically, they're used in two different situations. If you're searching through text to find a particular word or character, or if you're looking for a value that marks the end of the input. So if you have to open a file, a lot of times, you don't know how long that file is, but there's going to be an end of file character eventually. And so that would be the sentinel that we would use in the Boolean expression to identify when to stop running the loop. So sentinel loops can occur with ranges, not necessarily a specific value that it's looking for. And the example that we give you here is that we might be having a random number generator generate numbers, and we want our loop to continue running as long as it's an odd number. And as each random number is generated and each odd number is fed in, we'll actually start creating, we'll keep track of the total, the sum of all those odd numbers that are being generated. And then at the end, we'll figure out what the average of those numbers was. But we really don't have any control, of how many numbers we're going to be using here, right? It's going to be determined by when we get an even number, which when you hear a problem like that, I should point out, then you should start thinking using the modulus operator, taking any number and seeing if you can divide it by 2 and if there's a remainder or not. That's how we determine whether they're even or odd numbers. And the other aspect of this, too, is you want to recognize what the bounds and the goal are going to be for these types of problems. So the bounds here is if an even number is generated, then we'll exit the loop. The goal is to output the sum and the average of all the odd numbers that are generated before we reach an even number. Okay, so here we're taking a look at the problem we just talked about, the Sentinel range problem we just talked about on the previous slide. So you can see that we set it up so that we have the scanner class so that we can take input, in this case, from the user. Instead of random numbers being generated by a random number generator, the user is the random number generator. And then we create a couple of variables, sum and count. So we're going to keep track of how many values, or in this case, odd numbers, is what we'll be counting so that we can come up with the average at the end of this problem. And then sum is just going to be a running total of all of the odd values. So then we take input from the user, and that's assigned to value. Then in the Boolean expression for the while loop, we're using the formula, the expression value modulus 2 does not equal 0. So as long as that expression evaluates to true, that means it's going to be an odd number. It's not going to be an even number, because even numbers, if you divide an even number by 2, you will never have any remainder left over, right? So that's what we're testing for. So if that's the case, if the test says it's true, that means we got an odd number, so we'll just add that value then to the sum. Again, a running total. We're using the plus equal operator there. And then also incrementing the count variable so that we'll know how many numbers were collected. And then notice too, within the while loop now is we're running the enter a number prompt to the user again, and then also assigning to value the number that they're typing in there. So that's pretty standard with while loops. We will have to duplicate that, which may look a little bit odd, but that is okay. That is good coding there, because the first prompt in the assignment to value has to be completed before the while loop begins. See, we're priming the while loop at that point. We're getting the initial value, and then once we're in the while loop, we want to just keep prompting them and taking in values again, as long as they do not enter an even value. And then outside of the loop, once the loop ends, once the user types in an even number, we're testing first of all to make sure that we have more than one. I mean, it could be the user started out by typing in an even number, right? And so that would mean that we'd have no count value. Count would still be 0 and sum would still be 0. So we're just checking to make sure that we do have at least one value in there, because we might end up with a divide by 0 error if we didn't make that check. So then if it is greater than 0, we go ahead and output the sum of the odd numbers is, and then the sum, and then the average value of our numbers, which is going to be sum divided by count. And then the else statement is just saying that no odd number was entered, right? So we've tested for that. We've allowed for that condition so that we don't have our program blow up with a divide by 0 error. So priming loops is important, obviously, as we demonstrated in the last slide there. Priming the loop means setting up the first value before the loop is entered. And it's important that we set up the loop properly. Typically, this involves getting first value just before the loop, again, as you saw, and then also repeating that step at the bottom of the loop. So again, that was all demonstrated in the last slide. Now, this does cause repeated code, as I said, but still, it's perfectly acceptable practice. So here would be a bad prime. Using our previous example, essentially, it's the same thing here. It's just notice that instead of taking a value from the user and using that initial value from the user in the Boolean expression of the while loop, here we have pre-assigned the value 1 to the variable value. So that's really not good practice. What is correct is what we showed you in the 2 slides ago, which is take the value in from the user, go ahead and prompt them, go ahead and assign the value that they type in to the variable value, and then again repeat that inside of the while loop. Because we showed you the bad prime, so here's the good prime. So this is just what we showed you before. It's just a little bit variation on that. So this is simplified. In this case, we're asking the user if they'd like to play a game. But again, the point is we're prompting the user. We're taking the value that they type in from the keyboard, in this case assigning it to a string that's named answer. And then we use answer in the Boolean expression for the while loop. And we're checking there to see if it's yes. If so, then we go ahead and move forward from that point. We have whatever statements that we want to have occurring there, and then again at the end of the loop we're going to check to see if they want to continue to play the game. So we just assume they're playing a game. They have reached some sort of a result. They were successful in accomplishing whatever the game was for, and then we're asking them, do they want to play again? That's generally how you do that in gaming systems. Now, it may not seem obvious to you, but comparing strings is not as easy as it looks, and it will help you to understand that strings are not primitive types. So they're not integers, they're not doubles, they're not chars, floats. They are a class. A string is a class. And that's because the primitive types, you got to remember back to the very beginning when we were talking about the stack and the heap, primitive types all go on the stack, and class types, which are also known as reference types, go on the heap. And that's because primitive types will fit within whatever the width of that stack is, and a stack is determined by the size of the CPU you're using. So most modern-day computers use a 64-bit CPU, so we can have up to 64 bits per line in the stack. Anything that exceeds that would have to be placed onto the heap. Think of the primitive types, and if you think about it, you'll realize that we had Booleans, which are really 2 bits. We have chars, which are 16 bits. We got ints, 32. We got doubles, 64. Those values can all be put onto the stack. But classes are going to be much larger than 64 bits, and so they have to be stored into the heap. What happens is the JVM would put the memory address from the heap, they put that into the stack. So that's why it's called a reference type, is that it's being referenced in the stack by its memory address. It's not the actual value that's being stored in the stack. So with that said, strings are classes, not primitive types, and objects like string can be created like primitive instances, just by declaring the type string and then following it by a name that we want to assign to that variable. But because they are classes, they have methods. We saw in the previous example, we were looking at a program where we had the length method and the @char method. So those are all, classes are much more complex. They have values that can be stored as well as methods that then operate on those values. So I don't want to get too deep on that, but just realize that objects are going to be much larger. They're reference types. So if you attempt to compare 2 strings, so the example that we give you at the very bottom there would be string S1, where you're assigning hello to it, and then string S2, assigning the exact same characters, hello, and then you try to compare the two, you would think that that would be true, that expression that you see in the if statement would be true, right? That S1 compares to S2. But again, you have to remember that the value is not what's being stored in the stack for string S1 and string S2. It's the memory reference to where those values are actually being stored in the heap. So technically, S1 is going to have a different memory address than is S2. So if we compare S1's memory address to S2's memory address, that would be false. And I guess I got a little bit ahead of myself here. This is the slide that then explains that all to you. So anytime you use the comparison operator for reference types, for objects, you have to remember that it's memory location that you're comparing, not the actual values. So the good news here is that objects will usually have an equals method. In the string class, it does have an equals method. So if you do the expression that you see there for the if statement, if S1 dot equals, and then we put in the second string, S2, in the parentheses, so that's the argument that we're passing to the method equals, then that comparison will evaluate to true. So that's the proper way to do that when you're dealing with objects. And in this case, we're focusing primarily on strings because that's where the error really seems to pop up, because you're learning strings early on before you get real deep into the classes and the reference types. Now, with that said and done, you probably are going to want to test out what I was just telling you about. So you went and wrote a little program, I'm guessing, where you created a string S1 and assigned it the value of hello, and then a string S2, assigned it the value of hello, and then did an if statement to see if it evaluated true or false, and guess what? It probably evaluated the true. So let me explain that to you. What happens is the Java virtual machine, when you create two instances of the same object, if it contains the exact same value, instead of creating separate objects in memory, in other words, two objects that had two different memory addresses, to be more efficient, the Java virtual machine actually would assign the same address to both of those. So in particular example, S1 most likely would compare to S2. It depends on the implementation, but most likely, if you're using Sun Java, that you're going to get that to evaluate to true. But that still does not negate what I was telling you previously. And so here's a good example then of how to test out what we were just talking about. So you can actually force the Java virtual machine to create two separate objects, meaning two different locations in the heap that contain the same value. Right, so in this example, you can see we're using the assignment. So we're declaring string S1 equal. Now we're using the new operator. And then in parentheses for the string class, we're passing to it ABC. So essentially, we're creating an instance to the left of the assignment operator there. We're creating an instance of an S1 variable, which is an instance of the string object with the value of ABC. And then doing that again for string 2, creating a new instance. String 2 becomes a second instance of a string that contains the value ABC. If you compare those, I guarantee you that will evaluate to false, because you've forced now the JVM to have two different address locations on the heap to store each of those values, even though they're identical. So we'll get on into reference types much later on and give you more details here, but hopefully you can wrap your head around that and understand how it works. So getting back to our looping, we showed you the while loop previously. There is what's called a do-while loop as well. And so do-while loops are bottom-tested loops. So the way that this works is you have the keyword do, and then the statements that we want to loop through, followed by a while keyword with the Boolean test expression. Now here, notice you do place a semicolon after the while in the Boolean expression. Remember when we were doing the while loop, we said, no, that's a no-no, don't do that. In a do while loop, yes, you must have a semicolon after the while and the Boolean test expression. So the way that this works is a little bit different than the while loop when you think about it, because what it's happening is we're actually processing those statements before we ever test any condition. And so that's why it's called bottom tested looping. So the statements that are in the body of the do while loop, those are going to actually run at least one time. Then we test for the condition. If the condition is true, then we continue back through the do while loop. If the condition is false, then we would exit the loop at that point. So that can create a problem. In fact, the do while loop is, as we see here, not the loop of choice. So beginning students tend to want to gravitate to the do while loop. It's assumed that this is probably because they don't need, or they don't have the wherewithal to prime their loops properly. So if you're thinking about using a do while loop, you should see if it is reasonable to instead use a while loop. And here's why. So as I said in the previous slides, that in a do while loop, the statements in the body are going to run before we ever test the condition. And sometimes that's what you want to happen. But this example, titled "The Cart Before the Horse," is really, if you think about it, what you'd be doing with a do while loop. So what we're asking you here is if you needed to test to see whether you wanted to add some salt or some seasoning to a soup that you're cooking up, would you just go ahead and add the salt and or the seasoning, whatever it may be, and then taste it? And then determine whether or not it needs more salt or seasoning? Probably not. I mean, I would think if you think about it logically, you would probably want to taste the soup first, determine at that point whether it needs more salt or seasoning, and then based on that evaluation, then you would add the salt or the seasoning. So that's something good to keep in mind when you're thinking about which loop type, while or do while, that you want to incorporate into your program. Now there are ways to jump out of your loops. So that's what we'll examine here. There are two statements that will force the code to branch. And so those are the break and the continue statement. So the break statement forces the loop to exit. The code will branch to the first statement, then it's past the closing brace of the loop. And that's whether it's a while loop or a do while or even a for loop. And then the continue statement forces the code back to the top of the loop. So there are times when you may be do an if statement inside of your loop and looking for particular conditions. You may want to go ahead and skip some other statements that are in loop and just immediately jump back to the top of the loop. And so the continue statement would work well there. It does work a little bit differently in the for loop and the while loop. So in the case of the for loop, the update expression will happen, then the test, the Boolean test. In the case of the while loop, the code will branch back to the test immediately without updating the counter variable. So here's an example of a break statement. You can see we have a random number generator here, so basically creating a variable RND, and it's going to be a random number from 0 to 100. So in the for loop, we're using I as the counter, initializing it with 0, and then we're testing to see, the loop condition is keep running the loop as long as I is less than 100, and then increment I each time through the loop. So basically what we're doing is we're generating 100 numbers here, 100 random numbers, and seeing what the random numbers are. The exception is going to be if the random number of 50 is generated. So within the for loop, you see that we have an if statement, and we're checking to see if the number that was generated by the random number generator, if it evaluates to 50. If so, then we want to go ahead and break out of the for loop. If not, then we just continually print the random number that was generated to the screen and then generate another random number and assign it to our num variable. and then go back to the top of the for loop and then continue the check again to see if the number that's generated is 50 or not. So the idea is that we're going to try and generate 100 numbers here, with the exception of if we hit the number 50 as a random number, then we want to break out of the for loop, jump below the for loop, and then do the if-else test. So then the if is just checking to see if our I is less than 100 or not. That will tell us that the number was encountered at, and then whatever iteration we were at within our loop there. So because we wouldn't be, we wouldn't have completed the full 100 numbers. And the else just says the number did not come up, meaning the number 50 did not come up while we were looping through there 100 times, generating random numbers, that the number 50 did not come up. So that's the break. We're actually jumping out of the loop. Here's an example of the continue statement. In this example, then, we're asking the user to enter a number that we're going to sum as we go through the loop here. So notice that we've set up the for loop where we have our I counter set to 0, and then the condition is that we'll run this loop as long as we're less than 10. So in other words, we'll generate 10 numbers. That'll be the default. So as the user types in a value from the keyboard, we're checking to make sure that they're typing in a digit. As long as they type in a digit, then we'll go ahead and add the value that they've typed in to our sum variable. And again, notice we're using the casting there to convert the value of char at into an integer. So we have a prompt where we're asking the user to enter an integer, and then we take the value that they typed in, assign that to variable s, and then we're testing to see what type of character was typed in by the user in the next line there. So we're using the char at method of the s string and then assigning that to c. In the if statement, what we're looking for is to see whether or not the variable c contains a digit. The way that reads, the Boolean expression for the if the character is not a digit, is essentially the way that reads. Right? So it's not character dot is digit. So the idea would be if they typed in a letter instead of a digit, it would hit the next statement, which is the continue statement, which basically at that point says go back up and loop again. In other words, it would redisplay the prompt to the user, enter an integer to sum. If it was a digit, then it would skip the continue and then it would go ahead and assign the value that they typed in to the sum variable there and increment I. So with the continue, we're skipping those next two lines and just going right back up to the prompt within the loop. So if you think about it, that's a good way to check to see what being typed in by the user and avoid any errors occurring, because you wouldn't want to start adding characters when you're trying to sum numbers. Now, as far as the nested loops go, the break and the continue statements will only affect the loop in which they are being used. So remember, a nested loop is one loop inside of another. So if in the inner loop of a nested loop the break statement occurs, then it only forces the code to branch past the closing brace of the loop that it's within. So if it's in the nested loop, it would exit outside of the nested loop, but it would go back to the outer loop. And that's the end of Lecture 6. Until next time, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.